Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. We're working on our geckos here for the demo deployment. The only thing is they don't, once you cleanse them, sometimes they get corrupted, sometimes they don't. So if we want to do some things, I think I want to hard code the X and Y instead of the random every time you spawn. And then we'll get them in hard-coded places, and then we'll finalize the speed. We want to do a thing here when we cleanse them. When we cleanse them, we want to boost their walk speed so they scatter off faster. And we also want to fade down their opacity because when they don't have collision detection with map objects, so we kind of need to fade them out to kind of prevent that gecko from walking over the edge there like we just saw. So let's see where we're doing this. It's called Gecko Road, where I'm putting them in, and I think we have... Oh, we do insert 3 of them. Okay, so they're not random anymore. But we do need to get some debugging for the entity system so that we know we're resetting their position correctly, as well as their corrupted status, as well as their state machine. So I guess for right now what we can do is maybe we could add some debug printing to the entities themselves. Let's take a look here at our entity class, and we have this thing where we're saying if the gecko is corrupted, let's move the particle system there. Well, when we go to render any gecko, let's just render out some debugging info. So we can print up some info like, let's look at its init values and see. I know it's probably better to find it in the entity defs. Let's look it up in the entity defs. And we find gecko. See, we have an animation table on a gecko. A corrupted gecko. Duke of God, what's up? Hey, I forgot to tell you yesterday, or 2 days ago, when you Prime subbed, I put your names in the credits as a supporter, because anyone who's been subbing or gifting subs, I put in the credits. So you're in the credited supporters now in the game, for your information. Thank you for the sub, dude. Yeah, I fixed the warp zones yesterday. Gosh, what am I doing? Love.graphics. Oh, in our entity, we just like half typed out our idea. Entity. Let's call this gecko debug, so we can find it again easy. And it's going to be a print, and then it's going to be whatever. So yeah, check out, we got the warp zone here to the dungeon, Duke of God, and then we got the fisherman's hut, which is warping, and then there was a bug on the mobile deployment where whenever you'd go into Mage's Castle, the game would crash on the mobile deployment. It worked fine on the computer. So we have the other house, and then the other house. I call them the Poke Center, the Poke Mart, and the gym. This is the gym. There's the mart. And then, so that's that plus the refinery. There's a couple of, I don't know, there's a lot of warp zones actually in the demo, because we still have the secret we have fast geckos in the forest, and then I put a secret a boulder covering the shortcut to Ice Mountain here. So if people go and get the green tunic down at the dungeon below, they can come up here and get that secret, which gives you eight potions. Which at that point, if you get to the 8 potions, you like, I guess you could go through the dungeon, have a trouble getting through the second half, being low on health, and then exploring more, and then coming to see that you get 8 potions through the shortcut in the dark forest up here. So that's kind of cool. I don't know why my camera was freaking out there. But yeah, so let's print up this info for our geckos, and I want to print up some fields that I know are doing certain things, like it probably has to do with the state machine for the gecko, which we have a gecko walk state. What is gecko walk state? So yeah, so the gecko entity itself has 2 states. It's either an entity idle or a gecko walk. So let's print up the state machine of the entity so that we know if we're at least resetting their state machine properly upon a scene transition. So let's try that. So it's a entity dot state machine, and then it should be a dot state name camel case, and we should be able to find it because I added that to the gecko walk state. If we look at what the gecko walk state is, I have this thing where I say state name. Oh, you know what? I don't. Okay, so now I have a dot state name here. This is what we're going to put in our gecko debug. Okay, so we're going to print up, we should have a dot state machine, just like how we're processing the AI from our state machine here. We're going to say love.graphics print, and we're going to print, we'll just print exactly what it is, which is the state name. So we're going to go on our own entity dot state machine, and we're going into the state name field to pull that string. It actually is a string already, so we shouldn't need to cast it, but muscle memory overtook, I guess. Let's just put it at, we'll put it at, since we want to render it like on the gecko, before we unshift our shifting logic here, we can say, and we'll just print this up at self x, self y. That would be at the same origin point, top left of the gecko, and we don't really want that. I want it to be, let's just shift it to the end of the gecko, pretty much. So we'll just do, I'm just going to put some numbers in there just so it's to the right of the gecko. So let's see if we get the state name. It should be idle and then corrupt once they kind of trigger on. So let's see. Oh, and I'm in a state 2. Okay, so they don't get initialized. Huh. State name is nil. So the state name is not from the state machine, it's from the current. No. What do we pass in as the state machine here, and at what point in time do we do it? Oh my gosh, dude. We don't even have self. How do we have this? How do we have a self dot state machine when we don't even assign it? How are we doing this? It should be in the gecko entity then, in the actual, because the entity has a state change method. Dude, yeah, where are we putting in this dot state machine? Where are we actually assigning? Is it not? Let me check the entity defs real quick. Do we put anything into a state machine? No, we don't. Okay, so map declarations, we must. Okay, so we go into. Oh, it's got two. Okay. Oh, okay. So it has, since it has. Yeah, we have to go into the dot current because state machine is a table of multiple state machine objects. So we have to actually do a dot current. So when we do this, it's not the state name because that field doesn't exist. That would be nil on the state machine, but on the state machine dot current state name, that field should exist. So let's see. We want to see idle and then walk from the geckos here. So we'll see idle, nice, and then gecko walk state, nice. We'll just put walk there. Okay, so let's see if they reset to idle. They should reset to idle. They reset to idle. Okay, so the problem is not. Well, maybe if they're cleansed, they might not reset to idle. Let's see. So I cleansed one of them. It gets deinstantiated once it's off screen. Okay, so it's not the state machine that's controlling, whether it looks or behaves corrupted. So that's not what we have to try to debug. So let's continue digging. And we'll put, it'd be not the current state name, but like the dot corrupted status. If it exists on the entity, which I think we define it in the entity. So they are corrupted, and once we cleanse them, they are false, so not corrupted. So now we're going to see if they remain false, which would be incorrect. So let's see. They remain true, so like they are corrupted, so it's just the animation that is having a bug there. So it looks like when we set the animation, we're not checking the corrupted status or resetting it upon a deinstantiation. So maybe I guess if we deinstantiate it, it's gone completely. So it'd have to be in the init. No. In the reset original positions, right? Let's check that because we have this function called reset original positions. And for geckos, nope, that's not it. It'd be for an entity here. Okay, so we reset to an original health, an original walk speed. If it's a gecko, we change the state. Okay, so maybe our type isn't changing? Because type, there's two different entities, and it probably should function differently. It should probably be. Why is my camera freaking out like that? I think it should be one gecko entity with different animations of the purple, because the purple gecko right now, if you look at the entity defs and look at gecko, we have a gecko entity with an animation of either walking, facing. Then we have this other gecko C, which is incorrect. Gecko C. So gecko C is just a different texture. It's basically the same thing, it's just a different texture. Hold on, I hear some buzzing in my room. I don't know what it is. It like sounds like it's electricity, but I think it was just my phone buzzing on the hardwood. Okay. Yeah, see, so in order to revert it back into a corrupted gecko, we need to always instantiate or reinstantiate on the reset position the animations to be a gecko C, not a normal gecko. So we'll see if our reset original position for our gecko has a also. See, it doesn't have a dot animations. We want to change the animation. We want to not like the animation is one thing and the texture is the actual picture that's going to load the purple gecko. So the animation is right. It's supposed to be idle. It's supposed to be idle state as well. But we need to literally change it. Just like when we cleanse a gecko into corrupted, we need to corrupt a gecko here on the init or whatever this is, or on the reset original position. So let's see when we do a change animation. I think it's. We want to find basically when we're going to a non-corrupted gecko. Change animation. No, that's not it. Oh, here, this is what we'd want to do. Yeah. This is what we want to do. Okay, so here, how does this work? We'd have to, we can run this just on the self. We can take out this map, go just to the entity itself. So just the self dot animations gets, and then we can say self create animations. So every entity has a create animations function, which we define right here. And we're saying, I believe we can declare this before we use it. Let me see. Okay, let's see if they go back to corrupted, right? Because it should be they're corrupted, they get cleansed, which flips a boolean of corrupted, but what's rendering if they're actually purple is actually the dot animations table. Oh my gosh, they're gonna kill me! Oh. Okay, yeah, he didn't get reset, but also I only reset when you leave and come back. See how he got corrupted there? When I left and came back, he got uncorrupted. Let me see if that works again. Let's. Okay, so all three are cleansed. Let's see if the reset original position pulls them as corrupted purple geckos again. No, it does not. But once they turn, then they're back. So at some point, we're running. Yeah, at some point, going from an entity idle to a gecko walk. Let's go see that real quick. It should be an idle to a gecko walk. Oh yeah. See, so this isn't changing any of the animation. All it's doing is running the change state. and the change state into a gecko walk probably has the trigger to reset the animation. So let's take a look at that. Gecko walk. There we go. So when we init a gecko walk, we do a change animation. If here, this is what it is. We're saying that our animations are going to be only assigned at the init. See, I think we can just get rid of all this because we don't really care if they're corrupted because they're supposed to get re-corrupted. So every time we init a walk state, or actually it should be in the idle state even. Idle state should just have this in the init. Let's see if the idle state has anything. No. See, so like, yeah, so since it defaults to the idle state, dude, I gotta fix this camera. Dude, come on. Why is it not wanting to do? Okay, that should be good. Oh, now I look yellow. Dude, what the heck? What's overriding this thing? I took this off. Sorry, y'all, trying to figure this out. This is a little annoying. Okay, we're going full auto, I guess. Okay, so this has nothing to do with the animations table of any entity. All it does is change the state. So when we're in the state, that's when we're saying, okay, well, going from an idle to the init, that's when we're saying it's corrupted, which is incorrect. It should be corrupted gecko from the get-go. Once we reset the original position, it should get restarted. But it could be simpler by saying here in the init, because there's a entity idle for this gecko. So if we go to that entity idle state for the gecko, we can say, well, how do we do it just for, you know, we want to say in the idle state, we just want to say the dot animations gets this if we're a gecko, because we don't want to assign Tashio animation or a bat any animation, because those are also entities. So we have to also see if it is a type of gecko, and we can keep the double check there. I mean, it's not completely necessary, but it doesn't hurt. We can say, you know, well, we have to, if the entity is corrupted and it's a type of gecko, go ahead and give it a corrupted skin. So now it shouldn't affect any non-gecko entities, and hopefully it refreshes every cleansed orange gecko into a purple gecko as soon as we leave the scene and come back. Oh god, come on, come on, stay back. Okay, so there's 3 of them coming back. They're all purple. That's it. Doesn't mess up anything like bats. Let's check the dungeon and see if we screw up any bat entities. I don't think we did, because we ask the gecko, right? Cool. And bat's corrupted and everything, because we're still printing that. Okay, so it looks like we fixed our gecko thing. I do want to place them a little bit more intentionally, because right now if you walk from here to here, you kind of get kissed by one. So I want to place them out a bit different. So let's do the one that is, it should be It's like 3.9 or something on the XY. So let's go to our gecko road. And we'll go to... I think what we want to do is go to our gecko debug first. And we'll stop printing up the debug, and then we'll go... I call it gecko road. It's where we instantiate them. What I say it was 3.9. 3.9 is the other one. Probably this one. 2.8. We want him to be over more and down more, I think. So let's try that. Okay, are they too fast? They didn't get... Okay, this other guy shouldn't be 1 pixel away from the edge either. Let's scoot him up. So the guy that's on... I guess he was... No, he must have been this guy. I don't know if they should be in like a attack pattern or what. Do they get randomized every time? No. They were initially somewhere facing up because they got initialized that way. We could randomize a direction for them to spawn, which could be fun. That would be in a reset original position or in the idle init. We could... Is that too much? Is it necessary? No. I think here. Let's see. Is the other guy scooted off? I just don't want geckos only 1 square away from a scene transition, right? So like that guy's 2 squares away. So okay, so that looks good. So they walk here. They have to juke him over here. Oh shit. But yeah. Okay, is 3 enough? 3 should be enough, unless we make him slower. If we make him slower, we can add a bit more. Yeah, I think what we can do is kind of cut the speed on these guys, because there's some secret fast ones in the forest. And I want those guys to feel surprising because of how fast they are. So I think if we slow down these guys a bit, it can help. They all have the same activation period, right? They all have the same... Oh, maybe not. There's just a chance they get either 1 second or 2 seconds on the activation period. So maybe there's a better way... Maybe there's a better way we can cast a random float. Because the random int number on the math.random doesn't give a float. It just gives a int. So I'm wanting to do a wait timer, not of just either 1 or 2 seconds, but maybe 0.75, maybe 1.2, maybe 1.8, just so they activate at different times, and there's like not a decent chance that they all wake up at the same time. I want them to kind of stagger on. Okay, so the next thing we gotta do is up their walk speed when they're in their flee state. So that should be easy because well, I guess it might be in the process AI for the entity walk state. It depends on the state. Let's see. Let's go back to our gecko debug and we'll print up the state so we can see. So self.stateMachine.current name. Let's see. Idle state. I think they're still in walk state. I don't think there's a flee state. I think it's probably just in the AI function for them. Yeah, it's still just walk state. So we could make another state for them. We probably should. Let's see how we're handling the difference between the pursue state and the flee state in the walk state. Let's see that. Because see, we have to do this thing where we cleanse them. What the heck are we even doing, dude? This is so bare bones. Process AI. We have a velocity. We have an AI path. It's gotta be, well, this is the AI, huh? We're not even scaling this by delta time. This is bad. Oh, well, we're just changing directions. Oh, okay, yeah, we're just changing directions there. Okay. Okay. So if corrupted, I'm not seeing where we have the flee state stuff. Where do we have an entity cleanser? I don't see where we do a corrupted false on the geckos. We have one there, but like I don't see where that triggers anything different for them to walk off state, so that must be... The gecko only has 2 states. We confirmed he's still in the walk state. And this has a block for if we're corrupted, which the else block is right here for it. So we're mainly... Do we flip our dx or dy randomly when we're... Oh, here. Wow. Okay. Okay, well actually this is actually kind of cool, because this is the problem I was thinking. Instead of initializing a math.random 1 or 2, we can get a math.random from a table of 5 different floats or whatever. And then we put this, say give me a random index, and then go index into that and pull out the value. It's like not a hash map. I mean, it's just a table, but it's like... This is all that's happening is we're affecting the direction. There's no state. This is really weird, because you would think that we did do the geckos really early on, so I think we just didn't think of doing a pursue state, flee state like we do for the bat. Because all we're doing is actually changing it here. We basically say if we're dead, if our entity health is 0, then go ahead and just give us a new direction, and we're not corrupted anymore. That's all we do. So what we're trying to do is give an initial direction or a initial different speed, right? We want a flee speed. Right. Yeah, we want a runaway speed, maybe at like 50. This is fine. I just think we need a flee speed, and then we say walk speed gets a flee speed, right? Which is, we don't have this yet, but we're stubbing it out. Flee speed, maybe 50. Let's see where that is. So let's go. Yeah, let's go into our constants. And do we have speed? We have speed of other stuff. Let's just say gecko flee speed. Okay. Now we go back. This gets gecko flee speed. Okay, let's try to cleanse the geckos and see if they skitter off. Let's see. Nope. Alright, well their walk speed doesn't change. Let's make sure something else isn't happening with the dot walk speed. We could print it up. Oh, we have them inherit, like an original walk speed. But they only do that probably on a reset original positions. Yeah, we do modify by the walk speed times delta time based on the direction. So that's why just changing the direction gave them the logic as if they were fleeing. So either the dot walk speed is getting overridden, or I don't know where else it would be. Let's just print up. Let's print up let me just try this. We're gonna go to our debug gecko. Our gecko debug and say we're not trying to put the state name, we're trying to put the entity's walk speed. Let's try that. $15, $18, $18. Yeah, it's getting overwritten somewhere, so that we might have it overwritten. We're not changing states. We're not changing states for the gecko, so something's going down where we're reassigning a speed. We do assign a walk speed to an original walk speed. This might be the case in the gecko. No, this shouldn't. No, because we're just trying to change the walk speed once we're in the walk state. And that's not working. So the walk speed must be getting overwritten somewhere. Right here. What the heck is this? That's what we just added. Okay. But this is in the update. This is not... This is weird. If we're corrupted and we're dead, walk speed's 50. Because we become yeah, I mean, we just want to change the the walk speed real quick right here. Right beneath it, we say if the entity's a gecko and we're walking, we're setting it to either a positive or negative walk speed. Yeah. Then we're updating. Wait a second. Oh yeah, because we make our DX become our walk speed, either positive or negative, and we just update our entity's position. So walk speed, how come walk speed isn't getting triggered to... Walk speed is getting overwritten somewhere. Walk speed is getting overwritten somewhere, and I just don't know. We do set it. Okay, but we don't reset original position till we screen transition, so that shouldn't be it. Now, when we define them, they get their own walk speed. That's fine. We're just trying to change their walk speed once they're walking. This is us. Yeah, man, it's just walk speed. It's just an entity dot walk speed that we can't change. Just because we're initialized with one value doesn't mean we can't just override it. So, oh gosh. Walk speed, see this isn't the issue because we're not calling reset original position. If that were in the update, it would be the issue. Entity. Yeah, we just define our own walk speed by what we defined. Yeah. Yeah. I don't see it, man. I don't see it at all. Entity walk speed. I also don't see where we're overriding it, so this is just not right. We're printing up the entity's walk speed and it's 18 right now. We just tried to do this where we say, let me just try to put it here and just say regardless, if you're walking, your walk speed's 50. If this doesn't make them fast, then there's for sure something wrong. This should make them fast though, like really fast. Okay, so yeah, something's way wrong because... What's happening? Are we using walk speed? If we're gecko, we update our DX. We don't change our walk speed, dude. It doesn't look wrong. This all looks fine. What is going on? We can't say self entity gets a walk speed update. Why? Where are we overriding this? They're slow. Okay. I mean, it makes we have this line commented out, which is like, well, it probably was broken, just like we're noticing right now. where do we do all the walking stuff right here. So like we do it right here. We say, let's get our walk speed. Let's put it in our DY. Change our animation, and then we just use whatever DX DY. So this is where it's becoming the slow walk speed, which is just telling me that our DX is inheriting the slow walk speed, meaning that the dot walk speed is just not being, we know it's not working right. So when we process AI, we don't do anything to the walk speed. So where are we modifying the walk speed? Yeah, we get it from the definitions. That's fine though. That's in the init. We define original. That's fine. They don't change speeds. Map declarations just gets ran once. So the only thing that would be changing walk speed would be here in the entity. And we only have a walk state on the gecko other than the idle state. So as far as their walk speed, it only matters to the walk state. So what's so weird, dude, it's so weird. Something's overriding it. Because we can say, okay, well, our walk speed's 500 or whatever. And it's going to have the 18 still, right? $15, $18, $18, $18. So the geckos, as far as the geckos are concerned, they only have 15. So how about instead of changing it in the walk state, yeah, it has to be in the walk state. Like the DX and DY don't really get changed here. They only really just say, oh, just update our direction. Then if our direction is something, then we modify by our walk speed. We're not assigning walk speed though. So we're not overriding that. So we should be able to just say walk speed gets, because we know that field works because we're freaking moving. So if we were to just say self.entity.walkSpeed gets whatever current entity.walkSpeed times 4 is just multiplied by 4. Should be very nasty. It doesn't even do it. We're overriding somewhere. I really don't know. It sounds so simple. Like all we're trying to do is change the speed of the geckos at any point in time once they're going, and I can't do that. I've printed, I know what state they're in. They're in the walk state, I know that much. Because ideally, we want to change their speed once they get hit, right? Once they get hit, once they become cleansed, which we do. This does just like the health check, right? So this doesn't determine whether or not it got hit or whatever. This thing... Oh, you know what? Wait. Oh yeah, we only flip corrupted to balls if we're dead and corrupted. Yeah. But then... the walk speed doesn't matter here, like, so like, because it's like, yeah, and this is where I would think it goes, but it doesn't change based on the walk speed, and it doesn't ever change based on the walk speed. We can't update walk speed. Walk speed is just being like inherited over and over and over by whatever walk speed it is. It's the only thing I could think of. Because we overwrite walk speed in the update function and it still is 18. So it's got to be in the entity class. It just has to be, right? It's got to be inheriting a walk speed. And not in the init in the update. Because like the init's one thing. Yeah, we got a walk speed. We don't do anything with it here. All it is, or you know, this is a line of code that I think would be responsible, right? It's overriding our walk speed with the original, which is the 18, the low numbers we've been seeing. So if we take this out, was it in fact part of this function call, even though we didn't intend to use this function here? No. So when we reset, yeah, we do want to reset walk speed because we don't want them to keep the fast walk speed, but they just don't have the fast walk speed. So this is only when we call the function. So dude, I've looked through all, I feel like I've looked through all the relevant stuff and I don't see the answer. Yeah, because right here, like the direction of the gecko determines where it's walking. And actually, we're updating position here. Hold on a sec. What the heck? What the heck? We should be doing this, where we update our walk by our DX. Why aren't we doing that? Because we're actually moving our Y position. This should be DY. Not Y. What is this? Right? Yeah. If we're facing down, well, this is how we actually move. Well, we don't want to move here, we want to move here. This is where we want to move by updating based on our dx and dy. So we set our dx, dy either positive, negative. So this is why we're not doing... We need to scale, well, see, and this is what's weird is we had our walk speed will need to modify our dx or dy, not our x or y. That's why it's not taking in walk speed. It's not even doing that proper. So this is the line where it's messing up. So if we're walking up or right, we have a dy of 0. Why? What are we doing, dude? Let's try this. Dy gets to be a walk speed times... So down is a positive dy. Now, if we're walking up, that's also dy. And we change it to be equal to our walk speed. That is a negative, so we can move upwards. Scale it by delta time. Okay, if we're moving left, we want to change our dx. And our dx will be a negative walk speed to move us leftward. And if we're moving right, we want a positive dx so we can go rightward like this. So now we are moving by dx and dy in our gecko walk state, and our dx is modified by our walk speed. So now when we change our walk speed via gecko walk state, if health is dead, we want to say, okay, well now our walk speed is now going to become, let's just say 100. So we're looking for this 100 change on a gecko death. Let's see. Their walk speed, they should speed up when we cleanse them. Oh, see that? Now they're actually modified by walk speed. Nice. This means it'll work. Maybe not. 100 is just a very slow walk speed. Right? It's what the heck is the walk speed of a player? $60? How come 100 is so slow? We are in fact updating by walk speed on the geckos. Something's still wrong though, because we're using walk speed as to factor in our change in position. Okay, so our walk speed, we need to times this by 60 if we want a normal number for the speed. So yeah, we'll just times this by 60 to get a normal walk speed, right? Because the walk speed gets cut in half into 60th chunks, but we want that walk speed maybe not. I mean, because let's just see if the walk speed times 60 close to decent speed, because 60 should be the player speed. So right now I think we put 100 and he is just bone slow. So like, oh god, where are we? Oh god, what happened? What happened? Dude, no. Dude. Okay, so let's see if this is closer to the right number, because we don't want to be screwing up the scale. If our player's 60, our gecko's 60, walk speed should be the same. So they're 18. That's looking, I mean, that's fast. That's way fast, even though it's 18. Right? Yeah. Okay. So how's our player? Oh, we might be getting this twice. You know what? We might be getting this twice. We might be getting it based on the direction and based on, well, I don't know, because the walk state and the entity class, I think both share a couple of lines, and one of those might be dx and dy. I'm just going to try taking out dx and dy and see if that makes him move still, because if it does, then something like what I'm thinking of is happening, and we're doubling up. Okay. So we're not. Okay. So I guess what we can do, how do we handle our player DX? That's what I want to know. I want to see where we're doing our player velocity update. So it's probably in the player class. Really? Where? It's got to be in the entity class then. If it's not here, yeah, it's got to be in the entity. Okay, so we have to be doing a DX gets something. It is in the entity class. So we are applying DX already in the entity, so we don't need to apply DX to our X position ever again, because the entity takes care of that. So we don't need to add DX. So maybe that's why I had those commented out. These are gecko walk state, right? Now, we don't want to do this. We don't want to do this. We just want to modify the DX and give us the proper DX dy. And then we'll see. Okay, let's try that. Nice. Okay, they're 18, I'm 60. That feels about right. Okay. So we can do a couple of things. We can try changing the walk speed once we cleanse now. So let's try that. Okay, right here, we're going to say, well, our entity's walk speed at this point in time is going to be 100. And we change direction, which changes our DX, and then walk speed will scale our speed over time. So it'll just be like, he'll run off really fast. I don't know which direction, but they should run off really fast. Come on. Get him. It didn't do it, man. They stopped changing. What the heck? That can't be the only change we had. They stop. Why are they stop getting hit? What did we change? Dude, why do they stop getting cleansed now? We didn't change anything other than change walk speed. It shouldn't have changed. Because getting them cleansed, all it is that one line where we change the walk speed, and that isn't working either. Yeah, they just stop. They just stop caring, dude. Corrupted false. New direction. This has got to work. This has never been broken, right? Like, there we go. Okay, so he cleansed that time. Why does changing a walk speed prevent him from cleansing? Let's try it again. What the heck? Dude. Dude, we just looked at the get diff. Nothing was substantial to where it would stop the geckos from getting transformed. Like, what the heck? Our get diff was like, we had put a walk speed there. We took it out for running it just here. Okay. All right. Yeah, we don't have reset original positions. We create this gecko. Animations. Okay. Dude, we're not changing anything that would screw up the gecko's transforming, right? Idle state, we're saying create the animation. We do that up here too, so one of these is unnecessary. We either create the animation in the original position or we put it here in the idle state. Init. And then all we did, we changed how it walks by modifying only its dy instead of its actual y, because our entity class handles our y position update. And we just changed our velocity here in the state machine. So we say we're gonna get a positive velocity to move downwards. We're gonna get a positive velocity to move upwards. No, a negative. We might be doing the parentheses wrong. Negative walk speed. No? Should be right. Can you do a negative walk speed like that? Because that's the only thing we changed is like that's the only thing we changed is the freaking the dx or dy. So if he's behaving different now, it's probably because his dy and dx is different. Okay, so let's do... We multiply all that. This is gonna be negative. This is gonna be negative. Can you put a negative like this here? Down is gonna get heavier. Walk up is negative. They don't care, man. They don't care. They don't care. They don't get uncleansed or anything. Okay, instead of doing... let me think this through. Because ideally what we can say is, well, now the dx is going to be whatever we want. Effectively, whatever we want walk speed to be. So let's try this again. Yeah, let's just do... down is going to be positive. Let's just say that gecko walk speed, right? Gecko flee speed. Okay, walk up times -1. I don't know if putting the minus in front worked. I don't know. But left is going to be a negative. Right, positive. Okay, yeah, just like that. Okay, so now all we're changing is just like the flat walk speed. We're not doing any of the dx or walk speed adjustments. We're just putting in an enum there. Let's see. Much faster, much faster. Dude, they still don't cleanse. And now they're killing me. Because I thought this was... oh, this is just in general. Okay, gecko walk state, we'll say if you're corrupted. See, so what's happening here that they're not getting a random direction and they're not getting cleansed, man. Because that gets the clean animation right there. Oh gosh, what the heck, dude. This gets the clean animation. This gives them direction, which gives them dx, which changes... oh, actually, I think that's the problem. Because this direction, they're getting modified based on their direction. Yeah, because in their direction, then they're going to go apply their new dy or dx. What the heck did we used to have here that worked? We used to have this where we say we update our position by our current position scaled by our walk speed. So we actually updated our position. Okay, we're gonna try the... I don't like how we used to do it like that. I just think it's so stupid. Okay, well... Yeah, basically our dx dy and our walk speed is tethered into the entity's direction, because I think there's some entity logic that is using direction. So if we want to speed it up, let's see, because our entity, let's look at just our entity. We should have a direction. Okay, well we aren't applying any positional things here to the direction, but I guess it's during the walk state. Okay, gecko walk state. See how we have a direction, and we're saying, well, if our direction is down, we're updating our Y position, which we shouldn't have to do. Because our entity is handling our positionals. So if we're moving down, we want actually a positive walk speed. So we're going to say gets a positive walk speed. If we're walking up, that's a negative walk speed. If we're walking left, that is a negative walk speed. Walking right, positive walk speed. Okay, so now we just have our walk speed, but now we need to we actually put our walk speed into the dx. So now the dx should be handled by the entity class. So we do give a specific velocity depending on the direction. So it shouldn't affect how we cleanse the geckos. That should work fine. They should just now walk off screen once they get cleansed, and that should be it. No. Why are they missing getting cleansed here? They stopped getting collided. What the heck? What the heck? We need a state machine for them, because this cannot be allowed. I can't hit them and they can hit me, man. That's not cool. So yeah, when we do it right, our game breaks. And when we do it really wrong, it's fine. So it's like, since we want it adaptable, we have to rehaul it to do the right way, because it's just not working. So I might be back later today and stream. I think I'm a little out of steam on this at the moment, but yeah, Duke. It's just sometimes you just hit your head on the wall on the same problem and don't fix it. Let me think if I could fix it before I end stream, because it's like, we're changing the correct thing, which is our velocity, instead of changing our position. So either our velocity is getting overwritten by some other thing. Let's print up. Well, yeah, the weird thing is it always ends up, all they do is they just walk towards you still, and they're corrupted, like they don't get cleansed. So why would changing whether or not we're affecting their position change whether or not they're getting cleansed? Which doesn't make any sense to me, because if we turn back our old method, they get cleansed, don't they? Yeah, they get cleansed no problem on the old method when we dude, that is just so weird. Why would changing our DX affect whether or not they're corrupted? That doesn't make any sense. Yeah, they don't get cleansed. Well, yeah, I mean, I'm going to have to hunt down this bug, see what's causing this. I think the move is we just have 2 state machines, one pursue state and then one flee state. So I think that's the answer, and we will just change the state instead of doing the if corrupted and collided with a spellcast, then update its walk speed sort of deal. We'll just say flee state, boom, we have a set walk speed, set update function, and then we won't have to deal with these issues. But thanks for watching. We'll be back. I might be back later tonight if I'm feeling up to it. We only dropped 0.6 of the frames. Guess still, that's still like almost 1 in 100. Thanks for watching. We're almost done with the demo. We have 2 NPCs to add, and then a little bit of playtesting fixes, and then we're going to be done with the demo, and we'll hopefully have it on Steam in the next month. I'm hoping for the 20th of September to have it up on Steam, but I don't know what the process is, and the playtesting is probably going to take a little while, so we'll see how that goes. But I'll run credits here, and then we'll find someone to raid, and we will call it a day. I might be back because it's a little unsatisfying where I didn't fix the things I was trying to fix today, so we'll see. Okay, I don't know this guy, Coffee Then Code, but we're gonna give him a raid and see what's up. So, oh, he won't allow raiders, so we will not raid that guy. Alright, thanks for watching, y'all.